This short lesson teaches Day Skipper students the basic principles of calculating times and heights of high and low water at secondary ports. We learnt in the previous lesson that almanacs provide tidal information for selected harbours around the coast for which the times and heights of high and low water have been calculated for each day. These are termed standard ports, and they may be major harbours such as Southampton, Dover, Greenock, or Belfast, or minor ones selected for their importance in the pattern of tidal behaviour. Almanacs don't have the space to give full tide tables for all of the hundreds of small so-called secondary ports around the coast. These secondary ports don't have a tide table or a tidal curve in the almanac, but instead difference tables are published that enable you to calculate and apply corrections to the times and heights for the associated standard port. Sometimes the tidal differences can be quite large, even over a small distance. In the Solent, for instance, the spring range at Portsmouth is 3.9 metres, and at the west end of the Solent only about 2 metres. So it's important to allow for the differences between ports. They may be larger than you expect. So if you are just using an almanac, you need to know how to calculate times and heights of tides at secondary ports. Although if you are equipped with a full set of Admiralty tide tables, or local tide tables, or a chart plotter, or mobile phone with a tidal prediction application, then you can obtain secondary port tide data directly, without the need for difference calculations. This used to be studied in detail at Day Skipper level. However, because it was one of the most challenging aspects of the syllabus, and because the RYA decided students would, instead, be better spending more time on electronic navigation, you only need to be aware of how it is accomplished, and the detailed calculation does not feature in the exam. So I'm only going to cover it in outline. However, if you regularly sail in and out of a tidal secondary port, by which I mean one which is not accessible at all states of the tide, then you're going to need a solution. Fortunately, there is an easy way to calculate times and heights at your secondary port using a local tide table, and I'll show you how to do this later. You do need to be able to use this simple method. Methods of interpolating secondary port information is covered to a greater depth in the RYA Yachtmaster Theory course. The flood tide coming in can be thought of as a wave, moving slowly up the coastline. As the tide floods northwards in this example, the high water wave will arrive first at Farlow, then Port Rampton, then Rawmarsh and Whale Bay, eventually reaching Namley Harbour, which we call the designated standard port for this area, and then on into the estuary beyond. So we can see here that the high water time is earlier at these so-called secondary ports, as the high water wave arrives there first. Or, indeed, it will arrive later, if the secondary port was somewhere beyond the standard port. The shape of the seabed and land have a huge effect on the heights and times of the tides. The information for any particular secondary port is linked to a standard port in close proximity. The reverse will be true for low water. As the tide ebbs out, low water will be earlier at Namley than it will be at Farlow, for example. First, we'll look at how a secondary port tide calculation is performed. Turn to page 65 in your almanac. Look backwards and forwards a page or two. You won't find any tide tables for Rozelle Cove because it's a secondary port. The table at the top of the page tells us that its associated standard port is Port Fraser, and there is an arrow indicating in which direction to look in the almanac to find the standard port tide tables. The table has 8 columns. The first column tells us that if high water at Port Fraser is exactly at 0000 hours, or at 1200 UT, then high water at Rozelle Cove will be 38 minutes earlier. So, for example, if high water at Port Fraser was at 1200, then high water at Rozelle Cove would be 11:22. Whereas the second column tells us that if high water at Port Fraser is at 0600 or 1800, then high water at Rozelle Cove will be 18 minutes earlier. So, if high water Port Fraser was at 1800, then it would be 1742 in Rozelle Cove. You will find, of course, that sometimes the data does not fit quite so tidily. There are very accurate mathematical methods of working out the exact differences, but we are not concerned with this in this lesson. Imagine high water Port Fraser was at 0900. 0900 is exactly halfway between 0600 and 1200. So high water Rozelle Cove would be exactly halfway between minus 18 minutes and minus 38 minutes, which is minus 28 minutes. So at 0832. The interval is normally, but not always, 6 hours, as these difference tables illustrate. And the difference might range from later to earlier, or vice versa, depending on where the secondary port is in relation to the standard port. Also, be aware that when you read a difference of, for example, minus 0110, this does not mean a difference of 110 minutes, but a difference of 1 hour and 10 minutes. Importantly, you also need to know that the times for high water at the standard port are given in the standard time zone for the port. For example, UT in the British Isles. This means that during daylight saving time, you must calculate the times of high water and low water at the secondary port based on the times given in the almanac, and then convert them to daylight saving time. Most of the time, we're not concerned with the exact time of low water in a secondary port, because tidal curves are centered on high water. But if you do need to find low water, it's exactly the same process. For example, if low water Port Fraser is at exactly 1100 or 2300, then low water Rozelle Cove will be 14 minutes earlier. A very similar process is used to determine the height of tide at high and low water. For example, if the height of tide at high water in Port Fraser is 4.2 meters, then it will be 0.2 meters more in Rozelle Cove. In other words, 4.4 meters, and so on. Having worked out the times and heights of high and low water at the secondary port, you can then apply them to the tidal curve of the associated standard port. So let's work through one together. If our draft is 2 meters and we want to allow a safety margin of 0.5 meters, what's the least depth we must anchor in at the anchorage in the north of Rozelle Cove at 1800 daylight saving time on the 17th of May if we are to avoid grounding at the next low water? The first thing to do is to calculate the height of tide at 1800 DST. High water Port Fraser was at 1447 UT, which is roughly halfway between a difference of minus 38 minutes at 1200 and minus 18 minutes at 1800. So let's split the difference and call it minus 28 minutes, giving high water at Rozelle Cove at 1419 UT, which is 1519 daylight saving time. The height of tide at Port Fraser at high water is 3.7 meters, which again is roughly halfway between a difference of plus 0.2 at 4.2 meters and minus 0.2 at 3.4 meters. Halfway between plus 0.2 and minus 0.2 is 0, so there's no difference at Rozelle Cove. The height of tide at Port Fraser at low water is 0.6 meters, roughly 1/3 of the way from a difference of 0.2 at 0.4 and 0.5 at 1.1, so let's call it a difference of 0.3, making the height of tide at low water at Rozelle Cove 0.9 meters. We can now go to the tidal curve for Port Fraser on page 51 and use the tidal data for Rozelle Cove. First, we write in the time of high water Rozelle Cove, then add subsequent hours up to the time we are interested in. Then mark the high water and low water heights at Rozelle Cove and draw a line to join the two marks. This new line is known as today's curve. Draw a line up from 1800, which is the time we are interested in. Because the range at Port Fraser is 3.1 meters, we interpolate between the spring and neap curves. Draw a horizontal line along from here to intersect today's curve, and from there draw up to the height scale, where we see that the height of tide at Rozelle Cove at 1800 is approximately 2.4 meters. So, if the height of tide at 1800 is 2.4 meters, and it's 0.9 meters at low water, the fall will be 1.5 meters. And if our draft is 2 meters, and we want a safety margin of 0.5 meters, it means we must anchor in a minimum of 4 meters at 1800 daylight saving time. We see here that when the tide falls by the predicted 1.5 meters from when we anchor to the next low water at 2156 DST, we will have 0.5 meters plus our draft of 2 meters in an overall depth of 2.5 meters. I know secondary port tidal height calculations are confusing, but don't worry too much. As I said before, you need to be aware of the full method that we've just been through, but you're not going to get examined on it at day skipper level. It's sufficient to have an awareness that further knowledge is required of the topic in some practical situations. Tide tables for secondary ports are published by national authorities such as the UK Hydrographic Office and by independent publishers. You should be able to purchase tide tables for the local area from a yacht chandlery, but if you berth in a marina, you'll probably be given a copy. Oh, and don't forget that you'll need new tables each year. Imagine that your home port is Rozelle Cove Marina on Strong Holm. You need some way to calculate height of tide at any time, routinely, for general navigation and anchoring in the area. As we've just seen, calculating the differences from the Port Fraser tide tables is a slightly arduous process. You can avoid all the tedious interpolations if you have a copy of the tide table for Rozelle Cove. Returning to the anchoring example we did earlier, the long way, now you just look up the time of high water and the heights of high and low water at Rozelle Cove in your local tide tables. Then plot these values on the tidal curve for the standard port for the area, which is of course Port Fraser in this case, and read the height of tide for any time you want. Having the tide table for a secondary port makes finding intermediate tide heights just like a standard port tide calculation. And tidal information is available for standard and secondary ports via a variety of different smartphone apps, and is incorporated in many chart plotters. Methods of interpolating secondary port information is covered to a greater depth in the RYA Yachtmaster theory course, but what we have covered here is sufficient for day skippers. Well done, you've completed this lesson. Now attempt exercise D.